Hello, everybody. Mr. Sharkey here. Um, Today, we're going to go through the acceleration note. So, if you can pull out your Unit 6 acceleration packet and follow along, this will give us a nice introduction to acceleration. We'll do a lab next class, and then acceleration is a pretty quick unit. Past couple classes, we've been looking at speed and velocity. And today we're going to start talking about acceleration. Our definition for acceleration is a change in velocity. So to think about definition, we have to think about our definition of velocity. So if you want to write a reminder to yourself over to the side, velocity is speed and direction. So that means that if we think about velocity, if we think about acceleration, there are three types of acceleration. We call these positive acceleration, negative acceleration, and then we'll talk about the third one here in a second. Positive acceleration and negative acceleration are the two types of acceleration that are going to come up the most. If we have a positive acceleration, that means that our object is speeding up, which means that we see an increase in speed. Negative acceleration, on the other hand, means that our object is slowing down, so we see a decrease in speed. The last type of acceleration that we can have is if an object is changing direction. Remember, velocity is speed plus direction. So if someone is turning, for instance, that is technically a form of acceleration because their velocity would change if they're driving north and turn to the east. That would be a change in direction. So that is a change in velocity. So these are the three different types. We can have positive acceleration, which means that we're speeding up, negative acceleration, which means that we're slowing down, and then we could also be changing direction, which is a form of acceleration. Usually when we calculate acceleration, we are just focused on positive or negative acceleration. So acceleration is a little bit different. We're going to set up a triangle just like we did for speed. Acceleration is going to equal the change in velocity divided by time. So a couple reminders to write ourselves. This delta V means a change in velocity. So this is not the first time we've looked at a delta, but as a reminder, the change in velocity is always going to be the final velocity minus the initial velocity. So if we ever have to find the initial velocity or the final velocity, we'd have to use this equation as well. But looking at the triangle, we can set up three different equations. Acceleration equals the change in velocity divided by time. Time equals the change in velocity divided by the acceleration. And then finally, our change in velocity equals our acceleration times our time. So these three equations are going to show up in class next time when we actually calculate some accelerations and then do some additional calculations. There is one thing that I want you to think about. If we're moving at a constant velocity, so if our speed is not changing, if our speed is not changing, if our direction is not changing, what is our acceleration? So I want you guys to take a second and try to think about this question. If you need to pause the video, you can, but I want you to come up with your own idea. What is your acceleration at a constant velocity? As a reminder, constant just means the same. Hopefully you've come up with an idea, but let's talk about this one together. If we're at a constant velocity, that means there is no change in velocity. So if there is no change in velocity, then our acceleration will be 0. There won't be any acceleration because we're not speeding up, we're not slowing down, and we're not changing directions. The last thing I want us to talk about up here with acceleration are the units for acceleration. Remember, when we're calculating acceleration is always a change in speed over a change in time. So the units that we use for speed will then be divided by the units that we use for time. So when we talk about acceleration, the most common unit that's going to show up is meters per second, or you could call this meters per second squared. Anytime we have a squared showing up in the time section of our unit, that's typically a cue that we're talking about acceleration. So we could have meters per second squared, we could have miles per hour squared, and then we could also have kilometers per hour squared, things like that. But meters per second squared or meters per second are probably the two that will come up the most. So I wanted to address those. All right. The next thing we're going to look at are some graphs. So we've got two different types of graphs. Position versus time graphs we looked at in the last unit. So this shouldn't be too crazy. How do we show speed on a position versus time graph? If you think back to last unit, the speed of the object was always the slope of our position versus time graph. So if we wanted to show a change in speed on a position versus time graph, let's think about that. If the speed is changing, that means that the slope should also be changing. So let's see what that looks like on a graph. Remember, when we're talking about acceleration, there are two different types that we're going to focus on. Started writing out position. So we can have positive and we can have negative acceleration. So I want us to look at an example of both of those. Both of these graphs are position versus time. But if we have a positive acceleration, that means that our speed is increasing over time. So on our graph, the slope should be increasing over time. If the slope is increasing, that just means that our line is going to get steeper and steeper. So if we have positive acceleration on a graph, it is going to look something like this. We want to write a note off to the side. Positive acceleration means that our speed is increasing, so our line should get steeper. On the other hand, if we are drawing a position versus time graph for negative acceleration, a negative acceleration means that our object is slowing down. So in order to slow down, the slope would have to decrease over time. So that means that our slope would have to start off really high, and then our slope gets shallower and shallower over time. So again, we can take some notes over to the side. Negative acceleration means that our object is slowing down. So that means that our slope is decreasing. Which means that our line gets less steep. Sorry, my handwriting isn't always the best on the iPad, so apologies. But now we've looked at position versus time graphs. So positive acceleration, which is over here on our left side, means that our slope is increasing over time because the speed is increasing, so our line is getting steeper. And then negative acceleration, which is our green graph, our object is slowing down, so the slope is decreasing, which means that it gets less steep over time. The other type of graph that we can look at, and this is a brand new type of graph, we can look at a speed versus time graph instead of a position versus time graph. We could also call this a velocity versus time graph. So just know that both of those terms will come up. For us, they're essentially the same thing, right? Speed and velocity are very similar. The only difference is that velocity cares about direction. So that leads us to our next question. How do we show a change in speed on a speed versus time graph? A change in speed means that our line would have to increase or decrease. So if our line is increasing, that means it has a positive slope. If our line is decreasing, that means it has a negative slope. So if the slope of our line is not zero, that means that the speed would be changing. So we would be accelerating. So our next question says, what is the slope of a speed versus change graph, or speed versus time graph? And here, the slope of the line is the acceleration of the object. So these graphs are going to look a little bit different. First off, these are always speed or velocity versus time graphs. So I'm going to go ahead and label my axes. And then just like we did last time, we will make a graph for positive acceleration, and we'll make a graph for negative acceleration. If we have positive acceleration, that means that we are speeding up over time. So the only thing that my graph should look like, if my speed is increasing, then that just means I'm going to have a positive slope. So if I have a positive acceleration, again, that means that the speed is increasing. So on this line, that just means I have a positive slope, which means that my graph is going up over time. On the other hand, if I have negative acceleration, that means my object would already be starting at a higher speed, and then its speed is decreasing over time. So my graph would end up looking something like this. So if I have negative acceleration, that means that my object is slowing down, which means that I have a negative slope. As a reminder, a negative slope just means that my line is going down instead of up. So these are speed or velocity versus time graphs. Up above, we have position versus time graphs. So the last thing that I want us to do is to fill out some notes about position versus time graphs and speed versus time graphs. So I know these are side by side, but let's go through them one at a time. Let's think about position versus time graphs. So these are the ones that we're a little bit more familiar with. On a position versus time graph, the slope of the line is the speed of our object. So if we have a flat line, if our graph looks like this on our position versus time graph, that means that the position of the object is not changing. So the slope is 0, which means that the speed is also 0. If we have a perfectly flat position versus time graph, that means that our object is not moving. The position isn't changing, so the speed must be 0. The second question asks if we have a straight line. So this could be a straight line that's going up, this could be a straight line that's going down, or a straight line that is flat. All of these graphs have a straight line. If we do have a straight line, that means that the speed is not changing. So that means that we are moving at a constant speed. If we think about the graph above, we had a perfectly flat line, so our speed was 0. At any point on the graph, our speed was still 0. So we do not have a change in velocity there. Let's look at positive versus negative slopes. So if I have a positive slope, that means my line is increasing. In this instance, my object is moving forward. Sorry, so many emails. So if my object is moving forward, this also means that I have a positive velocity. On the other hand, we could have a negative slope, which means that our object is moving backwards, or it's moving back to the starting point. We've seen some examples where we have negative slopes. This means that I have a negative acceleration. Or I'm sorry, not acceleration. This means that I have a negative velocity. So our object is moving back towards the start. The final example that we can have goes back to the notes that we took earlier today. If we have a curved line, again, this is a position versus time graph. If our line is curved, that means that the speed is changing because the slope of our line is changing. So that means that our object is accelerating. This graph on the left, since our graph is getting steeper over time, that means that we have positive acceleration. On the other hand, this graph on the right, our line is getting shallower over time, so that means that it's getting less steep or the speed is decreasing. So this is everything on our position versus time graph. The last thing we're going to jot down today has to do with our speed versus time graph. So on a speed versus time graph, the slope of the line is the acceleration of the object. So if we have a perfectly flat line on a speed or velocity versus time graph, that means that our speed is not changing. So again, the slope is 0, which means that our acceleration is 0. You might also hear a graph like this. We could describe it as a constant velocity. So if something has an acceleration of 0, we could also say that it's moving at a constant velocity. On the next one, again, if we have a perfectly straight line, so our line could be moving up, our line could be moving down, or our line could be moving sideways. But as long as these are velocity versus time graphs, this means, again, our slope is not changing. So if the slope is not changing, that means that our acceleration is not changing. So our object is moving with a constant acceleration. So let's look at each of these examples a little bit more in depth. If we have a positive slope, this means that our speed is increasing over time. So our object is speeding up. Which means we have a positive acceleration. If we have a negative slope, so if our slope looks like this, then our speed is decreasing. So our object is slowing down. So that means we have a negative acceleration. And the last example that we could have, again, if we're looking at a velocity or speed versus time graph, is if we have a curved line. So this one isn't going to show up a whole lot, but in the past, students have been curious. So if our line is curved, again, that means our slope is either increasing or our slope could be decreasing. But if our line is curved, that means that the acceleration is changing. So our object is either speeding up faster or slowing down faster. This is something that we will not see a whole lot in class, but I still think it's a cool thing for us to look at. So if the slope of our speed versus time graph changes, that means the acceleration is changing. Once you get to this point, you are done with the notes over acceleration, and I want you to turn to the next page where you're going to sketch a couple different graphs. These sketches don't have to be anything too crazy, so they can kind of look like the sketches that I've done here. But you're going to end up drawing 8 different graphs. 4 of them will be position versus time graphs, just like we have here. And then 4 of them will be speed or velocity versus time graphs. So go ahead and try to sketch those graphs out, and then you can upload a picture of your work, and that will unlock the key for you, and then you're done with today's virtual day. Thanks for working hard, y'all. I know notes aren't the most exciting, but this means we can do a lab next time and hopefully have a better understanding of our graph. Thanks, and I'll see you next time.